Hello and welcome to CPU naming conventions. I'm making this video to clear up some of the confusion that I have seen about Intel and AMD's name conventions. I know some people who are interested in computers, starting to get interested in this kind of stuff, and I remember there being a lot of confusion when I first started building computers, so I'm making this video to clear some of that up. This video will very minorly touch on laptops and will try to avoid HEDT. I started this video a while ago, back in February. Some things have changed since then. So without further ado, let's get into CPU naming conventions. To start, this is the CPU of your computer. You will either see something that looks a little bit like this for Intel, or something like this for AMD Ryzen. Underneath of this middle area is this, a piece of silicon. Silicon is an element on the periodic table, and it powers all solid-state electronics. The CPU stands for Computational Processing Unit, or Computer Processing Unit, and it basically just does a bunch of math. It is the brain of your computer. Every computer has one. Every computer needs one. Memory or RAM. This video will not get into the difference between different types of RAM and stuff, but you need to know what RAM is to understand CPUs a little. The GPU stands for Graphical Processing Unit. Not all computers need one, but it is definitely a good thing to have for gaming. I'm currently working on a GPU naming conventions, which are, to be honest, a little bit simpler than CPU naming conventions, but that might take a while. Storage, different than memory. Again, this video will very briefly mention these, and just like that, we're moving on. Your motherboard. Your motherboard is a connector. You plug all your components into your motherboard, and that is what powers it's what keeps everything together. You could hand wire all of this stuff, but it's basically impossible with the size of modern computers, and the motherboard is a convenient way to keep all your components together. Your PSU, or power supply unit. Computers draw power. You need one. CPU details. A CPU is made up of a few different components that you will not need to worry about, but it is a good idea to understand each part of your CPU. This is the silicon die of the CPU. This is what it looks like blown up to a huge scale. And this is all of the sections of this CPU die labeled. This is a 12th gen Intel CPU, which I will explain what that means later. And modern Intel CPUs, as you can see here, have two different types of cores. Here's one type of core, here's another type of core. Yes, one is bigger than the other. Yes, this one is better than this one, but that really doesn't matter for this video. So memory, RAM, details. Your storage is for long-term holding of your data. The interlink between your storage and your RAM, while fast, is not the fastest interlink. Storage is what is known as non-volatile, meaning when you power down your computer or completely unplug it from the wall, your data is stored. It will not be lost. Your CPU calls data from the RAM, which calls data from the storage. The RAM then holds this data for as long as the CPU needs it. The CPU will then call data from the RAM to process it. It will then use it and discard it, or use it and place it back on the RAM. And it does this by moving small amounts of data, megabytes or kilobytes of data, into the cache. Your GPU. A GPU is only one letter off from a CPU. They do very similar things. As you can see, this is the actual GPU chip. The whole thing is called a graphics card. The G stands for Graphical Processing Unit. Each GPU is very similar to a miniature computer, just at a smaller scale, and designed to only handle video output. Each GPU has an interconnect to the rest of the CPU through the PCIe slot. It has a GPU chip. It has video memory on a GPU board or graphics board. And it has a power connector over here. And as you can see here, this is what the GPU die looks like at a larger scale. As with the CPU, these structures cannot be seen with the naked eye. They are normally covered and only a few nanometers across, each one. So you will never see these with your naked eye if your computer is functioning as normal. But it is a good idea to understand what they do and how they work. Motherboard details. As I said, your motherboard is basically just a large circuit board with many different connectors. All motherboards have this pretty basic layout. The size and form factor might change, but they will all have these parts: a CPU socket, RAM sockets, or DIMM slots. A DIMM is one stick of memory. It's just computer terminology. It doesn't really matter. One or multiple PCIe slots. The by 16 just means the number of lanes. The number of lanes for each slot really doesn't matter. It varies from motherboard to motherboard. It used to matter, but it doesn't matter anymore. So all graphics cards will fit in a by 16 slot. They might not use all 16 lanes, but they all fit in this slot. You have your power connectors, other connectors. This one here is for storage, as is this one here. Other headers, USB. You have to connect your USB to your motherboard so it can interlink with the rest of the computer. And several other things that we're not going to touch on today. Power supply. It's the power supply. They come in two varieties, mostly for desktops. Modular, where you plug in all the cords, and non-modular. There are different rankings and standards for power supplies, like the 80 Plus Gold certification or PCIe 5.0. We will not be getting into those. The power supply is a pretty simple component, although getting a good one when building your own PC is pretty important, just because you don't want a shoddy power supply. That is how you lose components. Unfortunately, I will not be making a video about power supplies. You're just going to have to do the research. It's pretty simple research. Moving on. Alright, Intel. If you buy an Intel CPU, it will either look like this one here for older ones, or this one here for newer ones. You will learn what these numbers mean during this video. Intel Part 2. I often see people saying, I have an i7. Well, both of these CPUs are i7s. However, as you can see, one is drastically better than the other one. And it is not just a case of bigger number higher. For the most part, that holds true, but not always. So take a look at these two CPUs. As you can see, this one has a higher number and more letters. So one would think that it would be better. We'll have a look at that. I will explain why this is later. Let's start with breaking down these fancy numbers that I've been showing you. To start, look at this number here. Either the first 2 digits in a 5-digit number, or the first single digit in a 4-digit number. This is the generation number. For the most part, the year that it was released corresponds to the first number. So the 9000 series released in 2019. The 1200 series, or the 12000 series, released in 2022. This does not always hold true, but it's a pretty good indicator. Moving on, the product stacked indicator. As you can see, both of these are i5s, but one of them is clocked higher than the other one. And it has the higher number. for the most part, this number just means better. That's about it. Alright. These are the numbers that you will see for the product stack indicator. I3s will use a 1 to 3. I5s will use a 3 to 6. I7s a 6 to 7. And I9s an 8 to 9. This does not always hold true. There are rare standout cases, but for modern desktop CPUs, it's pretty simple. Moving on. Any extra indicators? So, this mostly only applies to older HEDT CPUs, which I said I would not cover. However, as you can see, this is a extreme edition, so Intel decided to add the 80. What this used to mean is a larger socket. This is no longer true, although there are rumors of it being brought back. Faster, more expensive. And in this is a case of higher number better. A 00, which is by far the most common, for desktops at least, is a more common socket, which doesn't really apply anymore, more common by far, and less expensive. Let's move on to the letters. The most common letters are by far the K and the F. The K means that your CPU is overclockable. It will also have a higher turbo clock. So what this means is, provided that there is a thermal threshold, so your CPU, when it boosts, when it turbos, will output more heat, but the K will boost up higher. So if there's enough thermal headroom, it will be able to boost higher and sustain that clock longer than a non-K CPU. This comes at the drawback of more power draw and a Z series motherboard. I will not be covering this. All it means is you need a more expensive motherboard to handle all that overclocking. The F. The F means no integrated graphics. Now what this means is all non-F CPUs have a GPU built in to the CPU. This can be useful for people who do not wish to buy a graphics card, such as office workers or people who are just using their computer recreationally and not for gaming. Getting one without the F costs less money because that part of the silicon die does not need to be manufactured. However, if something goes wrong in your computer and it all of a sudden starts outputting a black screen without a extra GPU built into your CPU, it can be more difficult to troubleshoot. Moving on to special case letters. The S, the X, and the XE all indicate special edition CPUs. They are more expensive, they are faster, that's about it. They're a lot faster. They're also a lot more expensive. As seen here by the 10900KF, which is overclocked, or it has the ability to be overclocked, and does not have an integrated graphics card. A CPU, so for example if this was a 10900K, would be slightly slower because some power draw needs to be sent to the iGPU, as well as some clocks need to be spent delivering data to that iGPU, even if that iGPU is not used. It's really not super much slower, but it is a couple percentage points slower. The 10980XE is a fair amount faster than the 10900. And this, while this number is from a synthetic benchmark, which is not always the perfect indicator of a real-world scenario, when the situation would be CPU bound, this will translate to higher frames for whatever game you're playing. More extra Intel letters. These are mostly laptop letters, or these are laptop letters. H, high performance. Your laptop will be faster, However, it will have a higher power draw, which means that your laptop's battery will not last as long. Performance. This is pretty average. It will come with lower power draw, but it will be less well performing than the H CPU. U, power efficient. A U CPU I would recommend not for gaming, because what it does is it limits the amount of power that can be sent to the CPU, usually on the range between 10 to 15, maybe up to 30, 35 watts. What this does is it significantly lowers the performance of your CPU. Mind you, if you are only using your laptop for browsing the internet, or if it's something like a Chromebook, this doesn't matter. HX, the highest performance. Your laptop will be able to boost higher and boost longer at the expense of heat, which laptops do have a hard time dealing with because there's a lot less room dedicated to cooling, as well as having the highest power draw of anything on this chart. Y, very low power draw. Same as the U, just lower power draw. Lastly, G, 1 through 7. This just determines the performance of the iGPU. Most laptops do not have an extra GPU because there's not a lot of room, there's not a lot of thermal headroom, and there is not a lot of extra power to go around. So, this is where your iGPU will be important. A higher number means faster graphics. I would still not use a laptop iGPU for gaming. I would recommend a dedicated GPU, which laptops do come with, depending on the model, or an eGPU, or external GPU. Intel Part 11. You might hear people refer to their CPU as a Alder Lake i7. This is just a way of determining the generation or microarchitecture. Microarchitecture is the actual silicon components put on the die. Usually, the more recent the generation, the smaller they are, which allows for faster clocks, less power, faster times to communicate between the different components on the CPU. So these are just the most recent names. These are not really super important, but you might hear people referring to them. So let's do a little performance test. Both of these are i7s. Which will perform better? Well, the more recent one will. That makes sense. Here we have two i9s. One of them is a special edition. Which one do you think will perform better? And that makes sense. Now, I would like to point out two things. One, the performance jump between one generation to another, while significant, is not as big a performance jump as it would be jumping from one product tier, like from an i5 to an i7. In most cases. So if you have an older i7, it might be more useful to jump to a higher tier of the same generation because the socket does change from generation to generation. Usually every 2 generations, every 3 generations. That's something that you need to keep mind of. So a switch in socket with a new CPU does mean that you have to buy a new motherboard, which might not be what you're looking for. And older CPUs can keep ticking for a fair amount of time. Let's take another look here. We have an i5 and an older i7, only one generation apart. One is overclocked. Well, what do you know? I was just talking about it. Moving on, we have an i5 and an overclocked i3 from the same generation. Let's see here. They're not too far off. Alright. we have an 11950H and a 12600. I'm going to stop saying things, and I want you to figure out the rest. Now, the only thing notable here that I will say is this H indicates a laptop CPU. So even though this i5 is an i5, or this i9, which is one generation behind it, is power limited. Now, I know I said that H is high power draw. I will say this. No matter what, a desktop, because it is plugged into the wall, will always have a higher power draw than a laptop. Laptops are limited by how much power they can pull from the battery, which is usually limited to prevent overheating. So, even though this is an i9, only one generation behind, it's also a laptop CPU. Now, that does not mean laptop CPUs are bad. It just means that you need to keep in mind that two CPUs with the same number, only one of them is in a laptop, will not perform the same. And this one here, we have a older i5, about 4 years before this i3, and it performed better. So if you have an old CPU that's not, only a couple years old, there really isn't a need to upgrade. Alright, moving on. AMD Ryzen. This is what older AMD CPUs look like. This is what newer ones look like. Underneath this metal piece, they both have a silicon die. Alright, just like how Intel has their famous I naming system, AMD has the R naming system, which stands for Ryzen. They made this to be able to compare the two CPUs. I will say this, the R3 is mostly retired in desktop CPUs. It used to be bigger, more common. It has since fallen out for most desktop CPUs. It can still be found on a laptop, but AMD laptops are even more confusing than Intel laptops and will not be super touched here. So, just like Intel, AMD has their generation number. Higher means better. This one came out more recently than this one. Product stack indicator. This next number here determines the product's location in the stack. I'll touch on this more in just a second. I will say this. AMD uses 900 or 950. The 950 is better than the 900 in the same generation. Why they don't keep the double zeros in both and they just shift the numbers around, it's marketing. Last but not least, generation. This goes back to what I was talking about. Intel also does this, but it's easier to explain with AMD. Each number increase in the generation number is also a microarchitecture improvement. This is the largest microarchitecture. This is the smallest. And each one comes with improvements. I will say this, you may notice that the 4000 and the 6000 do not exist, for these are only desktops. And that's because they don't exist for desktops, only on laptops. And also, the generation number is basically meaningless on laptops. That's about it. I think AMD's laptop naming situation, which was changed during the making of this video, is stupid. Last but not least, the extra indicator. I've only ever seen this used on laptops and never on desktops. Last but not least, you can show the product stack indicator. You can correlate it with each core, with the number of cores. if you think of a core as, you know, each core can do one task. So the more cores you have, the more simultaneous tasks you can do. That's not exactly how it works, but that's a good analogy. Now, you may notice the weird numbers here. Okay? And this is because underneath the hood of anything that says Ryzen will be something along the lines of this. The CCD, which contains all the cores, and the I/O, or input-output chiplet. Each chiplet contains either 6 or 8 cores, and that kind of makes sense for these wacky numbers here. Anything with a 600 in it has 6, so it only has one of these. The 5800 and the 5700 both have 8, so they only have one of these. The 5900X has 12 cores, so it has 2 6 cores. The 5950 has 2 8s. 8 times 2 makes 16. Pretty self-explanatory. The most common AMD letters are the X. X just means it's slightly faster, it has a higher max clock, similar to the K, except all AMD CPUs are overclockable, X or no. The X is usually a little bit faster for not that much more money, so if you can, I would go for the X. The X also has higher power draw, but this usually isn't a problem. The G, retired on 7000. So unlike Intel, prior, anything with a 5000, 5000 or above, does not have an integrated GPU. Which saves money for buying a CPU if you're never going to use it. However, not having one can make troubleshooting very difficult. I've never needed to use a iGPU, I don't have one, but there are times where it can be helpful. So, all 7000 CPUs do have an integrated graphics. There's no option to not have it, but any CPU with a G prior to 7000 has an iGPU. Next, there's only a few CPUs with the X3D label, and they have stacked cache. So recall back to the slide about memory, and I said that each CPU has some cache built into each core. The more cache, just like RAM, a CPU has access to, the better it will perform, basically. However, these silicon dies are very expensive to manufacture, and cache is something that can go wrong. So imagine if you had to throw out a whole batch of silicon dies, very expensive silicon dies, because there was a small issue in a few caches. What AMD does, what basically everyone does, is they don't put that much cache on the CPU, and they rely on you having a pretty good speed between the CPU and the RAM. However, AMD came up with a plan. If you make a bunch of dies that are just cache, they won't be that expensive. You can then place them on top of your normal core or CCD chiplet. It's called stacked cache, or three-dimensional cache, which is where the 3D comes from. However, due to all this extra silicon, and the heat, which would normally just go up and out of the CPU, is now limited by this cache and the extra silicon that doesn't serve a purpose that they had to put there to make sure it was all the same height, lowers the boost clock, and limited to no overclocking. Most people won't overclock, but if you ever wanted to, it's basically impossible on an X3D without voiding your warranty. For laptops, you have U and H, very similar to Intel. We'll go on to the figuring out which one is better. I'll let you do that. So as I said, marginally slower between the G and the non-G variant. And as you can see, large performance jump between modern generation and 2016 generation. Once again, pretty simple to understand. We have, a highest 16-core CPU versus an 8-core CPU of the same generation. Obviously, this one is going to win over this one. Here, X for overclocking, however H for laptop, power limited, so the laptop will lose out to the non-laptop. Okay, as you can see, the X does grant you a little bit of performance, a fair amount, but not that much. And there's also a small marginal generational increase. And that's about it for CPU naming conventions. There is a GPU naming conventions in the pipeline. This video really only applies to the last 10 years. Less time for AMD, because Ryzen came out in 2016, of CPUs, but it really has all you need to know to get started for picking out a CPU for a modern desktop. A few closing notes. I'm not a huge fan of i9s for average gaming computers, just because they offer so much performance, but you are often limited by your graphics card. And even then, you might be engine limited in the specific game that you're playing. Go with a more budget-friendly CPU that will last you a decent amount of time, and something with a 600 in it or an i7, and you'll be pretty well off for, at least 4, 5, 6 years. I personally am running a 10700KF. I've had it since 2020. I plan to keep it till I finish college. Be smart with your money and your CPU purchasing decisions, or just buy a pre-built. Nothing wrong with that.